All right, so number 14, you have something in parentheses to a power, which means that all of this stuff is to that power. And it's not distributive property, but it's kind of like distributive property. The most missed thing on a problem like this is that I'll just wait. The most missed thing on a problem like this is that people forget to take the number in front to the power also. So we can't forget to do that. That's 4 to the 4th. Okay, and then 2 times 4 is 8. 4 times 4 is 16. Negative 2 times 4 is negative 8. So 4 to the 4th, 2 times 4, 4 times 4, negative 2 times 4. Okay, there's two more things we need to do in this problem. First, we need to figure out what 4 to the 4th is, which is 256. And then the second thing is we circle this and we take the reciprocal and move that to the bottom and make that p to the positive 8. And the rest of this stuff stays where it was. Okay. Last problem. Use dimensional analysis to solve the following problem. Your favorite. Convert 300 feet per minute to miles per hour. Okay, so we start with 300 feet. And when this is a rate per minute, we go over 1 minute. So 300 feet per minute. Okay. Do you guys want to start with feet or minutes to fix first? Minutes? Okay. So how many minutes are in an hour? 60. And should minutes go on the top or bottom? Okay, so now we're going to work on the feet. Should feet go on the top or bottom? Bottom. Does anybody remember how many feet are in a mile? 1,280. Good job. If that is a problem on the test, we will put the 5,280 on there for you. I do expect you to know there's 60 minutes in an hour, but I don't expect you to memorize the 5,280. Okay, so we go 300 times 60, and then this is on the bottom, so we go divide by that. So 300 times 60 times is the top, and then divide on the bottom. 3.4 miles per hour. And I forgot to cross out the feet, huh? Okay, at this moment, your warm-ups should all be done. Can you look back through those? If you don't have any of some of those, you're gonna have to do them or get them off of the videos. They should be on all of the videos. Okay, now I'm going to bring you a paper, which we're going to do 92 through 95 on, not in your notebook. I'm gonna do it on this thing I made. Yeah, but, okay. Okay, now these problems are long. We're only gonna do the first two. And on the back, we're only gonna do one tiny piece of it to save you time so you can work on your sequences who done it. Okay. These are geometrics. And you can tell they're geometrics because it's got a percent in it. So I want you guys to find the percent. This whole lesson right here is geometric. You already know the geometric part of it, but we have never talked about percent increase or percent decrease. So this is the last thing in the chapter that we need to talk about. Okay. So it says 9 upright dominoes of increasing height are lined up to be knocked down. The dominoes are numbered 0 through 8. The smallest domino, 0, is 5 centimeters tall. And circle that 5 because that's going to be our start. Domino 0 will be toppled by a person to start the chain reaction. Each subsequent domino is 18% taller than the one before. What is the height of domino 8? Okay, we're gonna do a bunch of things for this. So each of these problems are long, but we're only gonna do 2 of them. Okay, so first, this is geometric, and geometric has an equation T of n equals T0 times R the n. And hopefully you would see y equals AB to the x living under there. Go ahead. Okay, you guys, and what are the 2 things that we need to plug into this for our equation? Yes, Landon? Okay, almost. So we need to plug in the 5. So T0 is definitely 5. You're correct about that. Okay, however, R is not 18%. Nope. Yes. 118%. Yes. Okay, so the clue here is that it says taller. Okay, so what you're gonna do is you're gonna say 100% plus 18%. It's plus because it's going up each time. So taller means it's getting bigger and increasing. You're going to add those together and get 118%. Yeah, it does. And then move the decimal over 2 spots. So R is going to be 1.18. So your multiplier is not 0.18, it's 1.18. Because you've got to get it back to itself and then 18% more. Back to itself, 18% more. Back to itself, 18% more. Okay, so okay. Now I'm going to start this table with you guys, but I want you to finish it on your own, which means you're going to need a calculator, but hold on real quick before you start. The start was 5. We knew that term 0 was 5. And the multiplier is times 1.18. So we're going to go on the calculator and go 5 times 1.18. And then what you're going to do is keep multiplying times 1.18 until you get all the way down here. So take 5.9 times 1.18 times 1.18 times 1.18 times 1.18. Everybody listen to me very carefully. Round to the tenths, just one decimal place, please. Do you know what I mean by that? Okay. I'm going to do it up here on my own while you guys do it. The next one I'm going to round to 7, by the way, in case you're wondering. The 10th, just one decimal place because our graph paper has like big squares, so we're not going to be able to get any more. 7. I rounded up to 7. Yeah. And then I just went in the calculator and did times 1.18. Just go times 1.18. Yeah. And then keep going. Okay, so I'm gonna put my table up in just a second, but mine might be a little different from yours because of rounding. It's okay. Don't freak out if we don't have exactly the same thing, but we should have close to the same thing. But I didn't round in my calculator, so if our stuff is not perfectly the same, it's okay. Here's what I got. I ended up with 22.2 at the bottom. And again, if you don't have exactly the same thing as me, it's okay. It just means we rounded differently. Yes. Yeah. Okay. So now what I want you guys to do is plot those points on the graph and don't connect them. They should just be dots. And what I'm hoping you'll see is that it's curving up. Does that make sense that it's curving because it's geometric? And then the last thing we're going to do for this is it asked us a question, didn't it? It said, what is the height of domino number 8? So number 8 will be down here in our table. Yes. I got 18.8, but it's just because we rounded differently. It's okay. It's the same to me. But I got 18.8. You put 19.1. It's close enough. 19-ish. Okay. Any questions about number one? We're done with it now. You good? Okay. All right. Now let's go over to number two. Go ahead, honey. For tax purposes, a car rental company assumes each car in the fleet depreciates, this is an important word, by 9% per year. If the initial value of a car is $32,700, what will the value be when the car is 10 years old? Okay, so first term is 32,700 because it says that's the initial value. And then for R, okay, it's a percent. So we have to do the percent thing, but depreciates. What does depreciate mean? Yeah, hold on. Yes. Okay, depreciate means goes down 9% per year. So you're going to write 100% minus 9%, minus because it's going down every year, is 91%. And then move the decimal over 2 spots. So R is 0.91. U of N equals 32,700 times 0.91 to the N. Asking us to go out to the 10 when it's 10 years old. So I made my table go to 10. Start with 32,700 and multiply by 0.91. On this one, I would round to the whole number because I don't know if you noticed, but the boxes are going by 2,500. So let me show you what I mean. I know. So on this one, I'm just gonna make this 27,079. Anyway, keep going till you get to 10. Okay, so when you're ready, here's what I got. The last one I got was 12,734. Again, you might have something slightly different from me because of rounding. And to be honest with you, the bigger the numbers in the problem, the more off we could be from rounding. So it's okay. All right, so last thing, graph the dots as best you can. It's going to be hard. Just graph them as best you can. And then we have to say at 10 years, it will be $12,734 or whatever you got in your table at 10. Again, your dots might not be perfect, but my goal is for you to see that they curve off. Just 5 minutes, please. I'm almost done, I swear. You guys will plan your bathroom trips accordingly. Not leave during this class a million times. That would be great. Okay, now flip to the back when you're ready. We're not going to do the whole thing for either of the two on the back. All I want you to do is to, on your own, try to identify term 0 and try to find R. Try to find term 0, try to find R. And remember, these are the percent things. So I want you to spend 2 or 3 minutes reading the problem, identify term 0, and identify R. And you can talk about it in your groups if you want. Okay, when you think you've done it, take a look at my answers. How do we do? So basically, all you have to do is just identify if it's going up or going down. Yeah. Yeah, this is all hard. And then you have to add to 100% or subtract from 100%. And then move the decimal bit. Okay, so rest of the period. You guys have the sequence, you done it to finish, and then you can work on the homework. I'm gonna come stamp as best I can. If you don't have something, It's okay, I wasn't here too, so I'm just gonna stamp as best I can.